Good afternoon. My name is Soumya Tripathi and I am going to present a presentation on bearing materials. In this presentation, I am going to tell about the basic introduction of bearing and the type of bearings. Then I will explain about the properties, the characteristics which are required in the bearing material, and then I will discuss about the various materials or alloys that are used in bearings to make bearing. In the basic introduction, we are going to discuss what is bearing. Now, what is a bearing? Bearing is a mechanical element that is used to support the load on the shafts and on the spindles. Shafts and spindles, which are used in automobiles, turbines, are subjected to different kinds of loading. This can be fatigue loading, that is cyclic loading, or it can be a compressive stresses. So these different kinds of loads act on shafts and spindle. Bearings support such shafts, the load which is acting on such shafts. Now the bearing can be classified as rolling contact bearings and plain bearings. So what are the rolling contact bearings? These are the bearings which do not use lubricant, but they have a rolling material. It can be a spherical ball or it can be a rolling cylinder, and the radial load is supported by such kind of bearings. Then we have plain bearing, which is also known as sliding contact bearing. In these bearings there is a journal. Journal is the part of the shaft which is present inside the bearing, and then there is bearing. The two surfaces, that is journal and bearing, are separated by a layer of lubricant. So that is known as plain bearings, and it is further classified as hydrostatic and hydrodynamic bearings. This was the basic introduction about bearings and the type of bearings. Now the most common material that is used to make bearing is steel, that is high carbon chromium steel, also known as chrome steel. So it is the most common element that is used to make bearings, and then this is hardened after machining. Now civil alloys can also be used to make bearings. These include nickel, chromium or molybdenum along with steel. So these alloys can also be used in making bearings. Properties of the bearing material. The bearing material should have low coefficient of friction. This is one of the most important property of the bearing material, that it should be having low coefficient of friction. This is because when coefficient of friction is low, there is less friction, and less friction results in less wear and less degradation of the bearing material. Hence the life of the bearing increases. So that is why the material should have low coefficient of friction. Especially the tin alloys which have high composition of tin, they can be used in bearing material because they have low coefficient of friction. Second point says that the bearing material should have less wear. That means it should be wear resistant. So the more wear resistant the material will be, the less will be its degradation, and the longer will be the life of the bearing. Also, the bearing is subjected to different kinds of load on the shaft. These include compressive stresses as well as fatigue loading. Fatigue load is the dynamic load or fluctuating load that acts on the shaft. So such load is also supported by bearings. So we require such a material for bearing which is having enough capability to bear such kinds of load, that is fatigue load, compressive stresses, and it should be able to resist or absorb, we can say absorb. Bearing materials should be able to absorb shocks and vibrations, because we know that bearings are used in shafts, moving elements, and such moving elements are subjected to jerks, for example in automobiles. So such jerks, shocks or vibrations should be able to be borne by bearing material. Such a kind of bearing material is required. Also, we require the bearing material to have high thermal conductivity. If its thermal conductivity is high, the bearing is not going to get heated so much, and the friction which is generated between the bearing and the rotating shaft or the journal, that friction produces heat. So that heat will not lead to enough heating of the bearing if the material has high thermal conductivity, because the heat is going to be dissipated to the environment. There are some other properties also which are required for the bearing material to possess. These include plastic deformation. It should have the ability to it should possess adequate plasticity. That means it should be able to plastically deform and should not be brittle, otherwise it is going to break. Similarly, we require adequate strength at high temperature. Bearings which are used in shafts of IC engine or high speed engines where the temperature is higher, so in that case, where high temperature application, in such kinds of high temperature application, bearing material should be used which is such that it is able to bear such high temperature. Then it should be easy to fabricate, and it should also be economical. It should be resistant to corrosion. It should be such that it is resistant to corrosion, and it should not cause excessive wear of the shaft in which it is rotating. For this to take place, the bearing material should be softer than the shaft material. That means the bearing material should be such that it is not wearing out shaft, and it should be able to maintain a continuous film of oil between the shaft and the bearing. Seeing all these properties of bearing, now we are going to see what are the different kinds of materials or alloys that are suitable, that have such properties, and hence they can be used as bearing material. First is Babbitt metals. This Babbitt metal means lead and tin alloys, and it was discovered by Isaac Babbitt. That is why it is named after the scientist, Babbitt metals. And these are the lead and tin based alloys. Then there are also cadmium based alloys. They are more expensive because cadmium is expensive. Then there are aluminum based alloys. Aluminum, as we know, is an excellent corrosion resistant, hence it can also be used as bearing material. Copper based alloys, especially bronze, that is the alloy of tin and copper. Silver based alloys are also used as bearing materials, but they are expensive. Then we have non-metallic bearing materials. Non-metallic bearing materials include Teflon or nylon, polytetrafluoroethene, that is the name of Teflon. All these materials can be used as bearing material. Tin and lead based alloys. So the tin alloys, high tin alloys are those that have more than 80% of tin, and high lead alloys have more than 80% lead. Then the composition is given here of Pb, that is lead, Sn is tin, Sb is antimony, and Cu is copper. The properties of lead and tin based alloys: lead is softer and brittle, lead is cheaper, tin has low coefficient of friction which is desirable in bearing material. Similarly, lead is used for medium and light loads, tin is used for heavy loads and for high speed, for example high speed engine and high speed turbines, while lead is used for railroad freight cars. If we see the binary composition graph in material science of lead and tin, that is the composition versus temperature graph, there we can see the solidus temperature of tin and lead as shown in the slide. What are the good properties of this alloy? It is able to embed dirt. Embeddability, the ability to absorb the dirt that comes in the lubricant between the journal and the bearing, that is known as embeddability. It should have good embeddability. Material should also be, it should have good conformability to journal. That means any kind of misalignment with the journal of the bearing should be adjusted. It should also have good shear resistance. Shear resistant means it should have good compatibility. and it should be corrosion resistant. So all these properties are good in the lead and tin alloys, that is why it is used. Then we have cadmium based alloys. Composition is given in the slide. It is more expensive, that is why it is not very common, and it is used in automobiles and aircraft industries. The properties of cadmium based alloy is that it has low coefficient of friction. As we have seen earlier, low coefficient of friction is desirable, and the reason was wearing, degradation of material, and bearing life. Then we have it has high fatigue strength, load carrying capacity, shear resistance, good embeddability, but it has poor corrosion resistant. Hence we use aluminum based alloys, because these aluminum based alloys have excellent corrosion resistance, and they are also conformal. They have good conformability, they have embeddability and compatibility too. They have high coefficient of expansion, used in diesel engines and tractors. Then we have copper based alloys. The composition of copper based alloy is given here. Bronze is the composition of copper and tin, and that is one of the oldest known bearing material too, and that reason is it has good corrosion resistance. It is hard and easily worked. We can see what is tin bronze, 10 to 14% tin, and the rest, that is 90 to 86% copper. Silver based alloys can also be used as bearing materials, but they are expensive. It forms a thin, in silver bearings, a thin layer of silver, about 0.3 to 0.5 mm layer of silver is laid on the layer of copper and nickel, on the steel, sorry, this layer is laid on the steel, and the intermediate layer of copper and nickel are used. So such a material is used as bearing material. It is expensive, highly priced, so it is only used when other materials do not provide us the satisfactory result. Non-metallic bearing materials include Teflon and nylon. Teflon, it has very low coefficient of friction. It is not easily reacting with water or other chemicals, and it has good thermal stability at high temperature. That is why it is used as bearing material. Similarly, nylon, it also has low coefficient of friction. The values are given for dry friction, for water lubrication. We can see here. So these are some of the non-metallic bearing materials which can also be used as materials for bearing. They are suitable because they possess the properties which are required for the bearing material to possess. That's all we have discussed about bearings, types of bearings, properties of bearing materials, and so we have seen these materials. In conclusion, we can say that the materials which are having low coefficient of friction, the materials which are stable at high temperature, these are some of the general properties which are corrosion resistant and which are able to maintain film layer between the journal and bearing, those that have the ability to bear excessive loads on shafts and spindle, those who are wear resistant with tough core. All these kinds of materials which have these properties can be used as bearing material. And we have also seen that certain elements like tin, they are very useful as far as low coefficient of friction is concerned. Then we have seen elements like aluminum, which is having excellent corrosion resistance. So there are several metals which have some properties which are very desirable. Similarly, there are several other metals which are having other properties which are desirable. That is the reason we are using alloys. Generally, bearing materials is chrome steel. It is one of the most common material of making bearings, but we can also use different kinds of alloys, and the basic purpose of using alloy is that we are getting many other desirable properties. And not only metals, we have also seen in non-metals are providing us excellent properties, like Teflon, as we have discussed, it is having stability at high temperature, again a desirable property. So we can, in this manner, we can search for many other materials, and we can check out that which of the properties are useful, and then those can be used as bearing material. To make bearings, as we know, different kinds of methods are used. Molding can be used, forging is used, even powder metallurgy has become very common nowadays. It is also becoming popular. So powder metallurgy and all the internal races and external races and the balls in the ball bearing, all these are made by these applications, by forging, molding, and then they are assembled together. So that is all about bearing. Thank you.